Let's go to Liquid 1861, rotating the box. So it gives us an uh, M multiplied by n matrix box. And in the box, there is three kind of characters. That is, a still is a char character, and also there is an obstacle which is a star, and empty that is a dot. So we're going to rotate the box 90 degrees clockwise. And because the gravity, those stones will go down when rotate until it hit an obstacle. So let's return the final matrix after rotation. So let's look at the example one, right? So this is a stone, and this is empty, and this is stone. So after rotate, initially it is an 1 multiplied by 3 and matrix. After rotate, it will become 3 multiplied by 1. And because of gravity, this kind of stone is going to, the first one, are going to drop down. So we'll return the result like this. The second one, after rotate, we'll see this one, because of gravity, it will drop down, right, until hit the obstacle. And the third one is a bit complicated, but since that it is almost the same, right? Only after rotate, only this kind of row or column is going to drop down, right? So then we can do two way, right? One is rotate first, and then um, manipulate on each column about the gravity, right? Or we can work on each row first. But the gravity is just like we push those kind of stars to its left, to its right, until it hit an obstacle, right? So that it will have the same effect that what we work on the row. And so for example, this one, what we do is that we are going to have a stone, and obstacle here. And this one will become this, right? If we move to the right and empty. If we work on the row first, then rotate, it will have the same effect, right? But the thing is that in this case, we just need to do for each row in this matrix, we use write a help function called work on row, right? And then the next step is doing the rotate. So let's write code for this. So what we do is that we are going to have for each row in box, we're going to write a help function called work on row, right? Then the next part is just rotate. Um, so so let's first is that rotate. Of course, we are going to have int m equals box dot length, and n equals box zero dot length, right? And our char result, it will be new int n m, right? So we need a return result. So we need to do a transition here. Okay. And the first thing is that we need to write a help function for the work work on row. So we pass in this row, right? So for this worker row, we just push every stone to its right until it hit of the obstacle, right? So we're going to enter n equals row dot length. We can use last stone position, right? Last not stone obstacle position start, right? Last obstacle position we set as -1 because we can um consider this one -1 as an obstacle, right? Can imagine this one as an obstacle on its left. So um, then what we do is that we count the empty space. Let's say as 0, right? So what we do is that for int I equals 0, I'm going to say I small equal to n, I plus plus. So what we do is that if I equals n, or this kind of row I is an obstacle, right? Then what we need to do is that we need to update the last obstacle as I. And also we need to count the empty, set this one as empty, right? The dot. Else, let's say, else if the row I equals dot sign, then we count the empty space, not increase. So if we have met an obstacle, right? And the things that we separate these kind of obstacles into two segments, right? And then we work on this part. We count how many empty spaces here, and we put the first part as empty space and the second part as stone, right? So what we need to do is that only when this kind of I, if this I minus last obstacle is greater 1, right? It's greater than 1. That means only um, if it is equal to 1, right? Means the previous one is an obstacle, right? Or the current is an obstacle. We don't need, there is no space here, right? No stones or space here. We don't need to worry about that. Only there is stone or space between these two obstacles we are going to handle in its middle part. So if there is space, what we need to do is that we'll say the start of the space, right, will be last obstacle platform. The end of the space, the segment will be I minus 1, right? What we do is that we're going to use, for example, j equals to start. For j is smaller than start plus count, right? This is the count of the dot. We need to put the first segment as dot, right? And what we do is that for the rest, j is smaller than equal to m, right? Or we can also write j smaller than I, j plus plus. For this part, we're going to have row j equals the stone, right? So this is a work on the row. Then we rotate. So for the rotate, let's see, so we'll have a row 1, column 1, right? And after rotate, let's say it will be this row, this row actually, you see this will be 0, right? So that is the m multiplied by row multiplied by 1 will become the new column, right? And this column will be its row, right? Column will be its row. So what we do is that if we know this transition, right, we just need to fill in the new result about its transitions. So what we do is that we're going to have for int I equals 0, I smaller than m. This is we iterate in the older matrix box I plus plus, and for int j equals 0, j smaller than n, j plus plus. So what we do is that result, right? So let's say it's old column will be new row, and older uh, m minus row minus 1 will be the new column, right? So we'll find in the older one that is ij. So this will be the transition, right? And then in the end, just return result. Else if, else if, else result if line 33, what's the problem? Else if row I equals dot is count, we'll count the, so this is actually should be, we have brackets have problem, right? So we should if should be us be here, right? Let's see. It should be chart. So doing like this, the time complexity will be uh, m, let's say for each row, and this is we are going to handle this kind of handle this kind of rows, right? Trying to push that to its right. And actually, we count. Let's say this is we just iterate from the left to right, put that into segments, right? So that is actually just one-time iterations. So this is n, right? Even we iterate twice, that put that again, but there is no iterate for loop. We just go through here, have a count, and then put this again, right? So it will be still n, right? So the time complexity will be n multiplied by n. And space is that also n multiplied by n. And the Python code is very similar. we can write the Python code as well. Let's write the Python code. So we're going to, for example, def and work on row, right? So we need a row. What we need is, for example, we are going to have n last obstacle count. N equals length of row, right? And last obstacle, let's set that as -1. And the count equals 0, right? So what they do is for I in range n plus 1, because otherwise we need to um, after we iterate this kind of n, we should also consider the last segment. So what do we say? If I equals n or a row I equals n star, right? So that is an obstacle. Then let's say if I minus the last is greater than 1, means two obstacles, there are more than one space, the distance is more than 1, right? So we'll have start and equals last obstacle plus 1 and I minus 1, right? So what we do is that we'll have j equals start from in range count. We're going to have row j equals dot, right? And we'll have j plus equal to 1. And for the rest part, I for this in range, so we'll say that is n minus start plus 1 minus count, right? So for this part, we need to put that as stone, right? So I have a row j equals this one, and also we need to have j plus equal to 1, right? And then for this if, that is if we have an obstacle, we are going to have last obstacle equals I, and we'll reset this space the as 0, right? So the dot counts. This should be the same with the if statement with the second if, right? If I and for this one, let's say else 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 if row I equals this dot, right? We just count the dots. The count should plus equal to 1, right? So this is work on the row. So for our main function, what we need is for row in box, we need to work on row, right? Then after this, we need to rotate. So let's also still get its length, and the length box 0. So our result will be multiplied by m for underscore in range n. So what we do is that for I in range n, for j in range n, so result j m minus I minus 1 will be the box I j. And then in the end, return result. That's all.